All right, so Unit 4 review. So Unit 4 was all about, well, really in a nutshell, the way I always kind of think about it. After a while, it's the whole thing. Y is equal to mx plus b. This was all that like equation of a line stuff, if you think back. So we had graphs where we would graph a line. It might look like that one, or it might look like, that one, or we even did straight lines, and we also did lines going straight up and down, right? That's kind of the end result. Like we can graph all of these things, but when we started like 4.1, it was more just about just in general, if we had an equation and put a number in. So here, I'm gonna give you guys some examples, and let's do a couple here. So in 4.1 stuff, like right 4.1, we had something like this, where I'd say if we start off with something like A is equal to 3n plus 1. And then I said, n is equal to 3, right? What's A equal to? Well, this is just a matter of like plugging in what we know n. So now n is equal to 3, right? N and 3 are the same thing. So I can just throw in 3 in place of everywhere that there's an n in this equation. But then some of you guys might be able to do it. You probably did this in your head already. But it's going to be 3, and then when it's 3 sides like that means times, right? So this is really 3. And what I like to do is when I replace the n or the x or whatever the variable is with the number, I put it in brackets. So it's 3 times 3 plus 1. So 3 times 3 is 9, and then plus 1, so it'll be 10. Okay, so that's the idea there. But now maybe you get a question where, well, you know what? Let's do. So that being said, let's jump to like one of those word problems ones, because I know this one kind of throws people off a little bit. So if this was our problem, right, and they all kind of take this form, the context will be a little different for everyone, but this one says John charges $10 to fix a computer, and then plus $20 an hour for his time, right? So if he's working on this, he's charging $20 an hour. Okay. And then the first one here says create an equation for this. All right, so I'm going to make my variables here. It's going to be profit, and then I'm going to make T like the hours that I work. All right, just instead of a Y and an X, it can be a P and a T. It doesn't really matter, right? But let's make an equation with P and T. So in this case, if I want to know how much John actually makes, right, it's going to be, I'll say P is equal to, and then I know for sure that he's making $10, right? He's making $10 no matter what. That's just, he charges $10. So I can just write that down and say, okay, well, he's going to make $10, but then he's also going to make, so plus, right? He's going to make as well $20 an hour. So $20 times every hour that he works, right? Because that's how you would. I'm hoping you guys will start figuring this one out, right? If you made $20 an hour and you worked 5 hours, you would go 20 times 5, right? You'd make $100. Like I'm hoping you guys are at that point that you could figure that one out. You should. By the time you're working, you should know how to do that. This is the same thing, right? I'm just saying 20 times the number of hours, and then just plus 10. Okay, and I wrote it this way, but you guys know, because this is review, you could have also written it this way too, right? 20 times T plus 10. Those are the same thing, right? You can move those terms around however you like. You can switch those. It doesn't matter, right? Just moving those terms around. So there's our equation, right? Either one, they're both correct. But just notice, just because we're going to be doing this in a minute, this looks a lot like our Y is equal to mx plus b, right? It's taken on the same form. So those will mean something if we actually graph this thing, which we'll do a little bit later. Okay, so now, so create a table of hours worked versus profit. Okay, so let's make a table. And I'm gonna make, typically you'd make this like your X and your Y, but in this case we've got P and T. So I'm gonna make this T and P. Okay, so let's say if I worked 0 hours, right? So at 0 hours, right? So if I just threw in, so P is equal to 20 times T plus 10. If I work 0 hours, that means I'd throw a 0 into this. That'd be P is equal to 20 times 0 plus 10. Okay, well, anything times 0 is just 0, so that would just be 10. And doesn't that make sense, right? He makes $10 no matter what. So that makes sense there, right? That he'd be starting at 10. Okay, so then let's do the next one. So if after he works 1 hour, so I'd say P is equal to 20 times 1 plus 10. Okay, 20 times 1 is 20 plus 10, that's 30. Okay, if you work 2 hours, then that's going to be P is equal to 20 times 2 plus 10. Okay, so 20 times 2 is 40 plus 10, that'd be 50. And we got a pattern happening here. I probably don't even need to plug this in, keep doing this. I could, but I could say, okay, at 3 hours, then do you guys see how this thing's going up by 20 every time? That's going to be the case, right? That's what a line does. A line goes up by the same amount every time. Actually, on both sides, right, it would go up the same. This one's going up by 1 every time, and this one's going up by 20 every time. So this would be 70. You can plug it in and check it out, but that will be the case, right? You get the same thing. Okay, so there's our table. And it says, how much will he make if he works for 5 hours on a computer? So we could continue our table, or maybe you'll just go like plus 20 to get there. But we have an equation for this. We'll say P is equal to 20 times T plus 10. Well, I can just throw 5 in for my hours. That's the beauty of an equation, right? So it'll be P is equal to 20 times 5 plus 10. So we've got P is equal to 20 times 5 is 100 plus 10. So your profit there would be $110. Okay, and so that's pretty much the gist of it. So you guys have a few questions like that you're going to be doing. While we're doing it, I wasn't really going to get that much into graphing yet, but let's graph this. Let's see what this would look like if we actually graph this. Okay, so I'm going to write y is equal to mx plus b at the top here. If you remember the b value, in our case, right here, and I'll write our new equation, p is equal to 20x plus 10, right? So our b is 10, right? Remember, that's where we start. That's because this is our profit up and down on the y-axis, and this is our time on this axis. So when time is 0, right? When time is 0 this way, like right to the origin here, then we're going to be up here at 10. Maybe I'll make that lower. I don't need to be up there. Oh, shoot. I don't need to be up there. Let's say like 10 was right there, right? So we're starting at 10, and then you'd be going up from there, and it'd be going up in a straight line. Okay, and then in a minute we'll get to this, but what's happening here is these are our hours, right? There's like 1, 2, 3 hours. Then for every hour you work, you would be going up $20, right? The 20, this isn't to scale. So you'd be going up 20, right? For every one of those. And that's your slope, right? That'd be 20 over 1. Your slope is your M value. We'll do more of that in a minute, but that's generally how your graph would look. All right. So let's do a few more, some other cases. So, well, let's say, yeah, I think we're good for table stuff. So let's get in just generally how some of these graphs will look. Yeah. So if I had, first off, let's go through our horizontal and our vertical lines here, right? So if you remember, if something like y is equal to 3x plus 2, then that would be like what we did above, right? That would be something that would do, something like this. It'd be a line on a diagonal, or another word for that is oblique. Okay, so if you see that in your assessment, that's what that means. Oblique would be like on a diagonal. But if you remember, if you had something like this, y is equal to 4. Just y is equal to number 4, right? There's no variable in this case. There's just a number. Well, the way that looks, would look is just a line, just a straight line going across at 4, right? This would be like y is equal to 4 right there. Because what that's saying is that your y value, right? This is your y value, and that's your x value. Your y value is like stuck at 4 everywhere. So no matter what x is, right? X could be 5. Doesn't really matter. X isn't even involved here. Your y value is going to come out to 4 no matter what. So that'd be a straight line on the horizontal. Okay. Now the other way, or the other thing that it could be, if you had something like this, x is equal to 2. You probably remember where I'm going with this. That x is equal to 2, that would be a straight up and down line where x, right? This is your x and that's your y, where x is 2. So that'd be straight up and down. So what that's saying is no matter what, everywhere, x is 2. So up here, x is 2. Down there, x is 2. X is 2 everywhere. So that'd be a straight up and down line. All right, so now let's look back into our y is equal to mx plus b. All right, so I'm going to bring up this screen. You can see on my graph here, so I've got y is equal to mx plus b at the top, and what this does is the slider lets me change what my m value is and what my b value is. So you can, it's nice because you can play around with this, right? Where I can see, okay, well, if I change my b value, right, like the second part of this, you can directly see what that's doing is the slope is staying the same everywhere, but my y-intercept is changing, right? So if I change up to 4.1, then it's crossing right there at 4.1. I can make it negative, or it'll just go below the x-axis there, right? So it'll be like down there now. Negative 3.8 would be down there. And my slope, so if I put this somewhere like that, so my slope now, remember, so positive slope is going to mean that it's like going up. So slope, let's see if I can do this. So slope, remember, is your rise over your run. Start this over. Anyway, there you go. Computer around so I can use my keyboard. Okay. So let's make our slope, or sorry, our b value maybe like 3. And now our slope, I'm going to make that like 2 over 3. Okay, so slope of 2 over 3. So what does that do? So what that is that I can take anywhere on this graph now, right? So the top part was 2. That's my rise. Right, that's my rise. And the bottom part is 3. And that's my run. So what that's saying here is that I have a run of 3. So that means that anywhere on this graph, I could start there and I go over 3. And then I have a rise of 2. And it doesn't matter where I do that. I'm always going to have the same case. So over 3, up 2. Or, it doesn't actually, you can do it either way. I could say up 2 over 3. It doesn't matter how you do it. The triangle could be above or on the bottom there of the graph, right? So, clear. Let's just do another one here. What if I had let's say, I'll just make it -2/3, right? So now you can see that the line's going down. It's like going down the hill. Well, now it's really similar, but because this is still like, it's called your rise, and this is still my run on the bottom, but my rise here, it's not going up 2/3 anymore. The negative, that just means it's going down 2/3. So if I find a place where it crosses nice, then I can go down 2, right? -2 or down 2/3. And that'd be happening everywhere. Down 2/3, down 2/3. It even works this way too, where I could take this point and I could go down, watch this, down 4/6. So down 4/6. So that would be a rise of -4/6. Okay, well, that simplifies to -2/3. The slope is always the same. Like, it doesn't matter what triangle you make on there, it would always simplify to the smallest fraction there. Okay, so hopefully that was making sense. Okay, so let's do an example like this. Sorry, I got to flip my computer again. All right, so let's say we had a question like this where it said, sketch the graph of, let's go like 2 plus 3y is equal to 4. Oh, 4x. All right, so first thing I noticed that this doesn't look like this, right? I need to be y is equal to mx plus b so I can see what the y-intercept is, and I can see what my slope is. Okay, so what I need to do, and we did a lot of algebra in the second unit, so this should be a little bit easier now. We got to do a little bit of algebra, and I want to get y on its own. Okay, so I need to get y on its own. Don't ask why. Okay, so the way we do this, right, is I got to get rid of, well, either the 2 or the 3. So which one of these goes first? And if you remember, I did like that onion analogy thing, like you got to work on the outside of the onion and work your way in to get to the variable. So the 2 has got to go first, right? The 2 is like farther away from the y. It's an easy picking, right? I can take that one. So we'll go -2 from both sides. We'll make that 0. So -2, -2. And then we write what we have left here. We've got 3y is equal to 4x. And then I can just go -2. I can't go 4 minus 2 on this side because they're not like terms, right? This one has an x in it and this one doesn't have anything. So that's all I can do. I just have to leave it like that. Now, I've got to get y on its own. So that 3 is the next one that's got to go. So I'm going to divide by 3. So divide by 3, those cancel. And now when I divide this side by 3, I gotta divide everything by 3, right? It's like all of it divided by 3. And then that's pretty much it. That is the equation of my line. So y is equal to 4/3x, which is the same as 4x/3, right? Remember, that doesn't matter, minus 2/3. And it looks confusing because you're dealing with fractions, but if we were going to sketch this, we got everything we need. So, oh, not that one. So if we're going to sketch this, we'd have, well, I'm gonna remind myself that it's y is equal to mx plus b, right? Where b is my y-intercept. So this is saying my y-intercept is -2/3. So -2/3. So remember, 3/3 would be -1, right? So I'm not quite at -1. So if this was, -1 right there, I'm right there. I'm 2/3 of the way to -1. So that's where I'm crossing. And then this thing has a rise of 4. It has a run of 3. Okay, so if I'm starting at this point, I can go up 4. So it'd be, 1, 2, 3. Here, I'm gonna just draw it. So this thing would go up 4 over 3. Okay, and that's enough. I've got 2 points. I'm probably good to sketch that thing. And then you would find the same thing. I could do this all the way up. You go up 4 over 3, up 4 over 3, up 4 over 3. So there you go. There is our equation of a line there, right? I think that should be good. So a little bit of algebra that you guys might need to do on some of them. Yeah, so that should be everything you guys need for that formative.